We want to write this as a single logarithm using our log properties. So what we want to do is we want to first of all get rid of these coefficients as exponents. So we end up with log m to the power 2 plus log n minus log p to the power 5. Now the bases are the same, so we can combine these logs. Positive logs are positive exponents, so they go in the numerator. Negative logs are negative exponents, so they go in the denominator. So we end up with log of m squared n over log p to the power 5. In example 5, we want to solve for x, so we need to get it out of the log. So I'm first of all going to convert it to an exponential expression. Get rid of that negative exponent. We're going to convert that to its reciprocal, and then cube root to solve for this. So the cube root of 125 is 5, so we end up getting x is equal to 1/5. In example 6, we're just going to use a change of base formula to evaluate this log. So we're going to convert this into log base 10 of 38 over log base 10 of 3. And inputting that into the calculator, we end up with 3.311. So I'm just going to round that to 3.31. This is a population growth or exponential growth problem. So exponential growth problems involve the following parts. So we have a starting amount. Okay, we have our starting amount. We have our multiplying factor or growth factor, which is the base of the exponent. And the exponent represents the number of times we use that multiplying factor, or what we're going to call the growth cycles. So here the population triples. So when we're tripling something, that's our growth factor. We're multiplying by 3. Now the growth cycles is related to 6.5 years. So once every 6.5 years, when the exponent is when the years is 6.5, the exponent should be 1. So in this case here, we don't have a start or an end, but we have our population increase of 10 times. So we're going to show that as our 10 is going to be the ratio of n to start. So we're going to divide out that start. Our growth factor, or we can think of it this way, we can start with 1, end with 10. Our growth factor is tripling. And our exponent then represents once every 6.5 years, so the years divided by 6.5. Okay, so every time we hit multiples of 6.5, we're going to increase the exponent by 1. So we need to solve this. So we're solving for the exponent, so we're going to use a log. So I'm going to use log base 3 of the argument is equal to y over 6.5. And then we can solve for y by doing this calculation. So log base 3 of 10 times 6.5. So calculating the number of years. So I'm going to do log 10 divided by log 3. And then again times that number by 6.5. And I get 13.62 years. So the number of years is equal to 13.62 years. And that's how long it'll take for the population to increase by 10 times. That makes sense because after 13 years is going to triple and triple, which is times by 9. So we need to do a little bit longer than that to get the 10 times increase.